Every galaxy in the universe is held together by something invisible. Not the stars, not the gas, not anything you can see through any telescope ever built. Something else. Something that makes up 85% of all the mass in the cosmos but emits no light, reflects no light, and has never once been directly detected by any instrument in human history. Dark matter. The invisible scaffolding that the entire universe is built on. We know it exists because of what would happen without it. The stars at the edges of galaxies are moving too fast. By the laws of gravity, they should fly off into space. The visible matter in the center of the galaxy cannot generate enough gravitational pull to hold them in. Something else is providing the gravity, something invisible, and when you calculate how much of it there must be to explain what we see, the answer comes back the same every time, in every galaxy, in every corner of the observable universe. 85% invisible, 15%, everything we can actually see. The woman who proved this was Vera Rubin. She spent the 1970s measuring the rotation of galaxies and finding, over and over, that the numbers did not add up without an invisible mass holding everything together. She published the evidence. The scientific community argued with her for a decade. Then they accepted it. Dark matter became not just a theory, but the foundation on which all of modern cosmology is built. Last month, a PhD student at Yale named Michael Keim pointed a telescope at a faint smudge of stars 67 million light-years from Earth and found something that should not exist. A galaxy with no dark matter. Not less dark matter than expected, not a lower than average dark matter halo. The stars inside this galaxy, a dwarf galaxy called DF9, sitting quietly in the constellation. Cetus are moving at exactly the speed you would predict if there were only stars and nothing else. No invisible mass, no hidden scaffolding. The galaxy that the laws of the universe say should not be able to hold itself together is holding itself together anyway. And it is not alone. New here, I cover what is actually happening in space right now with real numbers and real stakes. Subscribe. You will not want to miss what comes next. Before I tell you what DF9 is, I need to tell you what it was thought to be before Keim looked at it properly. When DF9 first appeared in astronomical catalogues, it was logged as a supermassive black hole. The object was so faint, so diffuse, so unlike anything in the standard galaxy catalogue that the automated classification systems did not recognize it as a galaxy at all. It was filed and forgotten, a misidentified anomaly in a database full of correctly identified objects. Keim found it during his doctoral work with Peter van Dokkum, the sole Goldman family professor of astronomy at Yale. Van Dokkum had spent years studying two other peculiar objects in the same region of sky, DF2 and DF4, that his team had previously confirmed were galaxies almost entirely devoid of dark matter. Both were discovered between 2018 and 2022. Both generated controversy that has not yet fully settled. When Keim looked at DF9 and recognized it as a faint dwarf galaxy rather than a black hole, he noticed something. DF9 sat in a straight line, not near DF2 and DF4, not loosely grouped in the same general region of sky. In a straight line, a narrow, linear string of 9 galaxies, including DF2, DF4, and now DF9 stretched across the NGC 1052 galaxy group like beads on a thread. A line of galaxies lacking dark matter has never been seen before. Those are Keim's own words in the Yale press release. He proposed using Keck Observatory's Cosmic Web Imager, an instrument in Hawaii built specifically to detect extremely faint starlight, to study DF9 properly. The team observed DF9 for more than 10 hours across 2 nights in October 2024. Then they did the measurement that changes everything. The way you weigh a galaxy you cannot touch is to watch how its stars move. Stars orbiting inside a galaxy move at speeds set by everything pulling on them: visible matter, gas, dust, and any invisible material present, including dark matter. If a massive dark matter halo surrounds the galaxy, the stars move fast. If there is no dark matter, the stars move slowly, at exactly the speed the visible matter alone can produce. The Keck Cosmic Web Imager measured the spread of stellar velocities inside DF9. The measurement came back with a total galaxy mass of approximately 100 million solar masses. 100 million times the mass of our Sunday. That number matches the visible matter. Exactly. If DF9 had the typical amount of dark matter astronomers would expect for a galaxy of its size, its mass should have been more than 10 billion solar masses, 100 times higher. Its stars should have been moving nearly 4 times faster than they are. That dark matter is simply not there. Keim's words about the moment the measurement came back. The findings provide some of the strongest evidence yet that these galaxies formed through an extreme and previously unseen process, and offers a rare new window into the nature of dark matter itself. But here is the question that the numbers alone cannot answer. How does a galaxy exist without the substance that was supposed to be the prerequisite for its existence? To understand the answer, you need to understand what dark matter is supposed to do before galaxies even form. The standard model of cosmology describes a universe where ordinary matter, the atoms that make up stars, planets, gas, clouds, and everything we can see is distributed roughly evenly right after the Big Bang. On its own, ordinary matter does not clump easily. It is too spread out and too uniformly distributed to collapse under its own gravity quickly enough to form galaxies on the timescales we observe. Dark matter changes that calculation entirely. Dark matter clumps first. It forms vast, invisible halos, regions of concentrated gravitational pull in the early universe. Those halos pull ordinary matter in. Gas falls into the dark matter well. It heats up, cools down, collapses, and eventually forms stars. Galaxies, on this model, do not form in empty space. They form inside pre-existing dark matter cocoons. This model works extraordinarily well. It explains the large-scale structure of the universe, the cosmic web of filaments and voids that Vera Rubin Observatory is now mapping. It explains why galaxies cluster the way they do. It explains the sizes, shapes, and masses of the galaxy populations we observe. And it says that a galaxy without a dark matter halo is essentially impossible under normal conditions. Because without the dark matter cocoon, the ordinary matter has nowhere to concentrate. Without the gravitational well, there is no seed for a galaxy to form around. DF9 exists, DF2 and DF4 exist. 3 galaxies in a straight line with no dark matter, in a universe where dark matter is supposed to be the prerequisite for their existence. So, what happened to it? The answer that Keim's team proposes is violent, literally. The 9 galaxies in the linear string, including DF2, DF4, and DF9, are all arranged in a straight line, pointing roughly toward a massive galaxy called NGC 1052. This galaxy group sits 67 million light-years from Earth and contains what the team believes is the forensic evidence of an extraordinary past event. The current leading model is a high-speed collision. Approximately 8 to 10 billion years ago, 2 massive galaxies, each carrying its own dark matter halo, its own reservoir of gas, its own population of stars, collided at unusually high velocity. Not a slow gravitational merger of the kind that happens constantly across the universe, where 2 galaxies spiral together over hundreds of millions of years and eventually combine. A fast, violent, essentially head-on collision. When 2 galaxy-scale objects collide at high speed, dark matter and ordinary matter respond differently. This is the critical point. Dark matter interacts only through gravity. It passes through other dark matter with essentially no friction. The 2 halos interpenetrate and separate, like 2 ghosts passing through each other. Ordinary matter, on the other hand, the gas that makes up most of the non-stellar mass in galaxies, is collisional. Gas clouds slam into each other. They heat up. They generate shock waves. They slow down and get left behind at the point of collision. The result of a sufficiently fast collision is a separation. The dark matter halos continue on their separate trajectories. The gas gets stripped out and deposited along the collision path, a stream of ordinary matter left behind in a line with no dark matter to accompany it. And when that ordinary matter gas, with no dark matter well to fall into, eventually cools and collapses, it forms stars anyway. Stars form because ordinary matter, under its own gravity, can still produce stellar nurseries, just more slowly and less efficiently than inside a dark matter halo. The result is a galaxy, or several galaxies, made entirely of ordinary matter, strung along the line of a past collision, with no dark matter halos of their own. DF2, DF4, and DF9 in a straight line pointing toward NGC 1052. 3 bodies of evidence for a single catastrophic event that happened 8 to 10 billion years ago and left behind these 3 galaxy-scale crime scenes along its path. Here is why this matters beyond the 3 galaxies themselves. The discovery of dark matter-free galaxies has been one of the most contentious findings in astrophysics since Van Dokkum's team first reported DF2 in 2018. The reason the controversy has been so sharp is that the existence of these galaxies has implications for 2 completely different and competing theories of the universe. The first implication supports dark matter as a physical substance, which is exactly what Van Dokkum argued, and what Keim's discovery of DF9 reinforces. If dark matter is a real physical substance that can be separated from ordinary matter in a violent collision, then its absence in these 3 galaxies is evidence of that separation. The substance was there. It got stripped away. The galaxies formed without it. Dark matter is real, and it is separable from ordinary matter, which means it behaves like a thing, not like a modification to the laws of gravity. The second implication is what makes some scientists uncomfortable. There is an alternative to dark matter called Mond-modified Newtonian dynamics. Mond proposes that the anomalous rotation curves Vera Rubin observed are not evidence of invisible mass, but evidence that the laws of gravity themselves work differently at the low accelerations found at the edges of galaxies. If Mond is correct, there is no dark matter to separate from ordinary matter, and therefore dark matter-free galaxies should be impossible. Their stars should still be moving faster than the visible matter predicts, because gravity works differently at those scales. DF2, DF4, and DF9 all have stars moving at exactly the speed their visible matter predicts. Not faster. Exactly as fast as the visible matter says they should move. Van Dokkum's co-author statement in the Keck Observatory press release captures the implication precisely. The finding provides compelling evidence that dark matter behaves as a physical substance rather than the effect of an alternative theory of gravity, particularly at the dwarf galaxy scale, where those theories are most heavily debated. 3 galaxies in a straight line with no dark matter, moving exactly as slowly as they should, is evidence not just that dark matter can be stripped away, but that dark matter is a thing that exists independently of the matter we can see. And the reason we know it exists independently is that in these 3 specific galaxies, it was stripped away and is no longer there. Now here is the part that connects everything. Vera Rubin spent her career being told her data must be wrong. The galaxy rotation curves she measured said something invisible was providing gravity. The establishment said she had made an error. She had not made an error. She spent decades accumulating evidence until the evidence was impossible to dismiss. The telescope that carries her name, the Vera C, Rubin Observatory in Chile, which began its 10-year survey of the universe on June 30th, 2026, is specifically designed to map the large-scale structure of the universe with precision that has never before been achieved. Its dark matter mapping capability, using a technique called weak gravitational lensing, which measures the subtle distortion dark matter causes in the shapes of background galaxies, will produce the most detailed map of dark matter's distribution across the cosmos ever assembled. And that map, when it arrives, will tell us whether the string of dark matter-free galaxies found by Keim's team is a local anomaly, a single violent collision that happened billions of years ago in a specific region of sky, or whether it represents something more widespread. Whether the collision model that explains DF2, DF4, and DF9 is a rare exception or a process that has been happening across the universe on a scale we have not yet measured. 3 galaxies confirmed, 9 aligned in the string, 67 million light years away. 1 violent collision 8 to 10 billion years ago that stripped the dark matter out and left the ordinary matter behind to form something that the model said could not exist. Vera Rubin proved dark matter was everywhere. Michael Keim found the places it is not. Both discoveries are telling us the same thing. Dark matter is real. It is physical. It is separable from ordinary matter. And the violence required to separate it, the collision energy, the time scale, the specific alignment of 9 galaxies pointing toward one massive neighbor is written in the positions of 3 faint, barely visible smudges of stars that nobody correctly identified until a PhD student at Yale looked at them properly and refused to accept the misclassification. Next, the total solar eclipse on August 12th crosses Greenland, Iceland, and northern Spain. For exactly 2 minutes and 17 seconds, the moon will block the sun's face completely. And in those 2 minutes, scientists will measure something no spacecraft has ever been able to measure: the outer atmosphere of the sun, visible only when the blinding disk is gone. What they find in those 2 minutes could change our understanding of why the sun's corona is 1,000,000 degrees hotter than its surface. A mystery that has remained open for 80 years. Subscribe. That one is in soon.